Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating blog post about significantly reducing the size of the DeepSeek-R1 language model while maintaining functionality. It's all about dynamic quantization.
Wow, sounds intense. So they managed to shrink a 720 gigabytes model, right? How much smaller did they get it?
Exactly. They achieved an incredible 80% reduction, bringing it down to a more manageable 131 gigabytes. That's a huge win for accessibility.
That's amazing. But how did they do it? Magic?
Not quite magic, but some clever engineering. They used a technique called dynamic quantization. Instead of uniformly quantizing all layers to the same bit depth, they selectively quantized different layers to different precisions. Some layers were left at higher bit depths, like 4-bit, while others, particularly the mixture of experts, MO, layers, were quantized to a surprisingly low 1.58 bits.
1.58 bits? That's mind-blowing. I'd have thought that would completely break the model.
That's the genius of it. Naively quantizing everything to such a low bit depth would indeed lead to gibberish. But their dynamic approach, which they've detailed in previous work on 4-bit dynamic quantization, allows them to maintain accuracy. They even used a clever importance matrix to calibrate the quantization process.
So what kind of performance are we talking about with this 1.58-bit version?
They report around 140 tokens per second on a system with 280 gigabytes, H100 GPUs. Amazingly, it even runs on a CPU with just 20 gigabytes of RAM, although significantly slower. They recommend at least 80 gigabytes total VRAM plus RAM for optimal performance.
That's impressive. How did they test the model's performance after quantization?
Instead of relying on standard benchmarks, they used a creative approach. They tasked the model with generating a Flappy Bird game, scoring it based on various criteria like color choices, shape generation, and overall functionality. The results were surprisingly good, even with the 1.58-bit version. They even included GIFs showing the original and quantized versions side by side.
I see. Interesting. So it's not just about the size reduction, but also about the architectural insights they gained. They exploited the DeepSeek-R1 architecture, right?
Precisely. They leveraged the fact that DeepSeek-R1 uses MOE layers. They identified specific layers that were less sensitive to quantization and left those at higher precision. They also highlighted the importance of the down_proj matrices in the MOE layers, drawing parallels with the Superweight's paper. It's a really detailed analysis of the model's architecture and how it impacts quantization.
This is fascinating. It seems like they've really pushed the boundaries of model compression. What about the code and availability?
They've made the dynamic quantized versions available on Hugging Face, ranging from 131 gigabytes to 212 gigabytes. They've also provided detailed instructions on how to run these models using various tools like llama.cpp, ollama, and VLLM. They even offer a modified version of llama.cpp with their dynamic quantization code integrated.
This is a significant contribution to the open source community. It makes powerful models like DeepSeek-R1 accessible to a much wider audience. I'm curious though, they mentioned some issues with chat templates and token mappings. Did they address those?
Yes, they did. They identified problems with padding tokens and BOS/EOS tokens in different distilled versions of the model, and provided solutions and corrected token mappings for various frameworks. They even provided a detailed table outlining the correct token IDs for different models and frameworks.
That's excellent attention to detail. It shows a real commitment to making their work usable and accessible. This whole blog post is a goldmine of information for anyone working with large language models.
Absolutely. It's a testament to their expertise and dedication to open source contributions. They've not only achieved impressive results in model compression, but have also meticulously documented their process and made their work readily available. A truly impressive feat.
I agree. Thanks for breaking this down for us. This is definitely a must-read for anyone interested in efficient large language model deployment.
You're welcome. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.